Hi guys, I have Mr. Frank Chapman here. He's actually the test pilot of the A350 on the A350 test program. So I'm very interested about the cockpit. Frank, could you show us about the cockpit feature on the A350?
Yeah, absolutely. We really started this design from the basic A380 design, and we asked all the companies what they liked about it, what they disliked about it, what they wanted in the new A350 cockpit design. The screens had moved on a long way from the A380 days, so we were able to bring these big screens into the cockpit. Because it's a particularly wide aircraft, we got 5 screens abreast, albeit the external ones are angled slightly aft. The external screens we use for what we call our electronic flight bag, which is all the paper documentation that we had in the older days, are now in electronic format, and they can be displayed on here along with the maps, charts.
Right, so the outside, this one is electronic flight bag.
Electronic flight
EFB,
bag.
okay.
And if, for example, mine fails, I can always look at the captain's screen.
So I have EFB on my side.
Too. We have independent EFBs.
Independent EFBs, so you can look at each other.
I can always look at his, and he can always look at mine. And if I want to share and discuss what I'm seeing on mine, I can bring it to the middle, and then I can discuss the departure or the arrival as required.
Right.
So that's the electronic flight bag setup. The panel in the middle, we have the autopilot panel in the middle, which is really for flying the airplane on the autopilot and adjusting altitude, speed, heading, etc. Outboard, we have the 2 control panels for the navigation display, for ranges, modes of operation, what we want to display in terms of waypoints, VORs, terrain, etc. And then if we look at the avionics displays themselves, we've got the systems displays in the middle, so I can call up the fuel page, for example, down here.
Yep.
The wheel page, and we've got multiple wheels on the A350, of course. The door page, see what the cabin crew are doing with the doors, whether they're open, whether they're closed, whether they're armed, and the engine page. And we also have, in conjunction with that, the page that displays the checklists. Here for the normal checklists, and up above it for the emergency checklist. So if we have something that's failed, then it would come up here in amber. Now, because we're not operating, a lot of the systems are shut down. We've got systems that are not operating and they're in amber. So the OAS, the captain and the first officer are in amber. It's saying there's a fault because they're not turned on, basically.
Yep. So, and of course I can see the joystick is next to you. That's the fly-by-wire technology.
Fly-by-wire,
a common technology.
It really hasn't changed since the A320. It's exactly the same stick. Works in exactly the same way. The interface with the flight management panel is down here on the left, and we have an alternate means of interface. This is the lunch table, but if you lift the flap up, you have an alternate means of interacting with the FMS,
right?
And inserting data.
So you're going to have left hand on your mouse, which is
left on the mouse,
and then on the keyboard.
You have a mouse and keyboard, and you have the side stick and the thrust levers, of course.
Right. And can I ask you about the A350-1000? You know, how much power this plane has?
Well, we're significantly more than the 900 because obviously it's a bigger airplane, so we need a little bit more power. So we've gone up to 97k on the engines for the 1000. Just carries
these
more
are
weight.
Rolls-Royce Trent, right?
Rolls-Royce Trent.
What's the
XWB? Is
XWB? That's the Trent XWB engines.
Yeah. So basically, we've pushed the engine a bit harder to get more thrust out of it. It's the same size as it is on the 900,
right?
But just producing a little bit more thrust.
Right. And what's the range usually with a typical payload? How long the 350-1000 can fly, the distance-wise?
Well, we could fly to Australia direct, but obviously with a reduced payload, and it's incredibly payload dependent. So it's hard to give you an exact figure. It really depends on how we're configuring the passengers and.
Right. I understand it can only fly. It can just fly about the same as 900, just a few hundred nautical miles short of the range of 900, right?
Correct. And we're looking at now extending. We'll always develop our aircraft, so we'll develop a long-range aircraft as well, a 900.
That's incredible.
Extend the range.
Incredible.
Okay, the head-up display in our aircraft is optional because it really depends on the destination as to the business case for actually including it on board. So we give the companies the option to...
Let me show the audience. You can clearly see now the HUD is turned on, and I can see you know, all the display about altitude, about the heading from the HUD.
And it's really a copy of the information that's on the primary flight display head up, so that the pilot can be keeping his eyes out the front of the aircraft, looking at the runway as he's making the approach, making sure all the parameters are spot on for an accurate approach and landing.
Excellent. How many years it took Airbus to develop the A350 program from scratch?
Well, we started work on the A350 just after the A380 entered service. So we're looking probably 2007 to 10, between 8 and 10 years, really.
10 years.
It's taken us to get to this point.
It's incredible. Thank you very much for sharing with us, sir.
Thank you.
Wow, this is my first time on board the A350-1000. Wow, it's such a test bed.
There's obviously no cabin equipment installed. Just the basics for us for flight test purposes. So there's a flight test engineer station, a lot of recording equipment, and as you see, it's a bare shell really of the cabin and galleys, which are obviously using a lot of electricity. The only way we can generate that type of electrical load is to have these load benches, and they're basically very big electrical resistors that draw a lot of current from the generators, simulate the full electrical load of a full aircraft, and then we obviously have to cool. There's a lot of heat generated in here, so we have to cool them. So there's a fan that pumps air through to keep the resistors cool, and it gets quite hot inside when we're running this system. But it's the only way we can simulate full load on the generators. It allows us to get into the cargo hold, and in fact we have water ballast tanks down there which we can use to move the centre of gravity if we need to in flight, as well as obviously burning fuel. We can do it, but we can actually shift water fore and aft to change the centre of gravity if we need to during the flight test. This is the flight test engineer station. We typically operate on many of the flights with 2 flight tests. It really depends what we're doing, but generally 2 flight test engineers, one sort of director and an assistant, and they can see all the systems in a lot more depth than we can see in the cockpit. So if there's slight temperatures going out of kilter, then they'll normally see it before we will, and they're really directing the test. So they will tell us when we can step from one point to the next. They will look at the results of the first point and say, yeah, okay, we're within our limits, structural limits, you can go on to the next manoeuvre, and so on and so forth. And that way we make sure we stay well within the structural limits of the aircraft, not only from a loads perspective but also from a systems perspective. They watch the systems to make sure the systems are responding as we expect them to respond. And the computers that drive the flight test instrumentation. So it's basically computers and hard drives. We can create a link to the telemetry room. So if we're doing a high risk test where there's more risk than normal, then we'll have a direct link to the ground, so the engineers on the ground can monitor the systems as well, just to provide extra level of safety and supervision. These are the water ballast tanks. We have them up front and at the back, and as I alluded to earlier on, we use them for loading up the aircraft to simulate passengers and freight and cargo, and also we can use them to move centre of gravity fore and aft.
How many tanks there is and how much weight it can give you?
Well, we can go up to well beyond the max takeoff weight or the planned max takeoff weight.
Just from all these tanks?
Just filling them up with water, yeah.
Right.
Yeah. For the flight test, we have what we call a trailing cone to do the anemometry, to calibrate the airspeed and altitude measurements, and or static pressure measurements, and we basically have a cone on the end of a 200-meter cable that's extended. We've actually taken out the equipment now, but there was like a reel here that would then go through up into the fin, and the cone would deploy behind the aircraft about 200 meters, and that would measure the static pressure static air pressure, so that we could calibrate our airspeed indication in the cockpit.
So this is all for calibration with the cone going outside the airplane.
Yeah.
I see. What's this thing here? This thing?
It's a pressure relief valve. So if the pressure differential between the inside and the outside is too great, then there's a spring there and it relieves the pressure. Because obviously the structure can only take so much differential pressure. And we have one going out and one coming in, depending on how the pressure balance is
Very
set up.
interesting.
With the 1000, we wanted to keep it as close to the 900 as possible, so that pilots could swap between the two. And I think we've done that quite well with the flight control system. There was a little bit of tuning to do to make sure the handling was similar on the 1000 to the 900. But we're now there. We're within just a couple of weeks of certification, and our first delivery will be in a month or so's time.